You're listening to the CaribClimate Podcast, produced by the Investment Plan for the Caribbean Regional Track of the Pilot Program for Climate Resilience, funded by the Inter-American Development Bank through the Climate Investment Funds and implemented by the Project Management Unit of the University of the West Indies Mona Office for Research and Innovation. Sea level rise will continue to affect coastal communities in the Caribbean due to the increasing impacts of climate change. The Caribbean Regional Pilot Program for Climate Resilience is improving access to high-quality data for adaptation planning to better protect lives and a way of life in the long run. In this episode of the CaribClimate Podcast, discover how geospatial data can help to improve coastal planning in vulnerable communities in the region. You'll hear from BSF Swissphoto, providers of Lidar Surveys to the Caribbean Regional PPCR project, and former program manager for the regional PPCR, Ainsley Henry. Ainsley provides some context to the impacts of sea level rise in the Caribbean.
All right, so in the Caribbean, one of the things that you might have heard people talk about a lot in the context of climate change is 1.5 to stay alive. There are multiple reasons why that term has been used, not least of which is the context of sea level rise. As small island developing states and more recently, large ocean developing states is what they're being called in some instances. A part of the problem is that with small land masses, any change is significant. So if we're having sea level rise, it compounds multiple problems. In the event of hurricanes, it means that the storm waters reach further inland. In the event of flooding, it means that the distance between the floodwaters coming down and the sea is much shorter, and hence the possibility of flooding is much, much greater. It also means that some places, for example, Hellshire here in Jamaica, they're disappearing. And this is not something that is unique to Jamaica, and it's not something that's unique to the Caribbean. It is something that is happening across the world in these insular states, island states.
Coastal flooding is a common occurrence.
Well, coastal flooding in the Caribbean context happens from two directions. In the event of things like hurricanes, as I mentioned before, you often have coastal flooding because of the distance inland that water goes. I don't know if you remember a couple of years ago in the Portland Bight area of Jamaica, Portland Cottage, a lot of communities in that area got flooded because a storm went by on the south coast. Essentially what it is that because of the way storms behave, as they move along the sea, they push water ahead of them, right? And in pushing the water ahead of them, that water rolls up onto the coast. And in some instances, people are actually walking in almost waist-high water. But of course, there's also the possibility of flooding from the other direction, which is when you have rain events for whatever reason, and, when you don't dispose of your solid waste properly and the gullies and streams are clogged and then the water backs up behind it. When that breaks, you have a rush of water coming down, and that also results in flooding. And of course, if you don't have proper infrastructure, that just compounds the problem.
The vulnerability of the Caribbean demands increasing need for geospatial technology and data to build resilience to natural hazards.
Yeah, well, this PPCR project had 4 components, and the first component was improving access to geospatial data and its management for adaptation planning and for impact analysis of sea level rise and storm surge. And as an activity under component 1, the acquisition of coastal nearshore topography and bathymetric data was needed for selected highly vulnerable locations in different PPCR countries. And the Mona Office for Research and Innovation, as the executing entity, engaged our company, BSF Swissphoto, in order to provide a few consulting services, like assist the PPCR countries with the selection of suitable survey sites evaluate options for the conduct of the survey, and identify the best technical requirements and most time and cost-effective approach in conducting the required surveys. Then also develop detailed terms of reference to execute the Lidar flights, and then monitor, evaluate, and supervise the data acquisition, and also do the quality control for the delivered products.
What is Lidar? Project manager from BSF Swissphoto, Emese Landtwing, defines Lidar.
So Lidar means basically light detection and ranging. So it's a technology, a remote sensing technology, and this acquires information on features of the Earth's surface without physical contact, so by means of laser measurement. This allows to make mass measurement and acquire much more data than otherwise possible with very good precision.
Originally, 4 PPCR countries were earmarked for Lidar surveys. However, the project conducted surveys in 2 countries. Lidar surveys collected bathymetric data, which captures underwater depth, and nearshore topographic data.
Yeah, so originally it was the plan to collect for 4 PPCR countries data for Jamaica, Grenada, St. Vincent and the Grenadines, and Haiti. But nearshore Lidar data was already available for the countries Grenada and St. Vincent and the Grenadines. So within this pilot project, we got Lidar and image data in the countries Haiti and Jamaica. So we got basically aerial image data, bathymetric and topographic Lidar data. And in each country, 3 nearshore coastal areas were selected. We went up to the 100-meter height elevation. So it's nearshore coastal data is the coastal zone in water area and also in the topographic area. So that basically you cover the coastal zone in the water and in topography, so that seabed data is available up to 30 meter, and then also in topographic part up to 100 meter inland.
There are a series of steps that must be followed to acquire Lidar data. Emese provides a breakdown.
So basically every airborne data acquisition starts with the preparation of a detailed flight plan for each project area. So for example, we had in Jamaica 3 coastal areas, and for each of these coastal areas a flight plan is prepared. And planning the survey flights means choosing the aircraft and sensor parameters to optimally fit the given project specifications and also the surrounding conditions. So, for example, important flight parameters are the flying height, at which flight level above ground level are we flying, then the ground speed, and also the flight line geometry. And then when these flight parameters are defined, then we need also flight permission from the air traffic control. And after the air traffic control says, okay, you can go ahead and you can fly, the systems are mounted on the airplane, and the data acquisition can take place when the weather conditions are suitable. Then in the aircraft, you have always 2 persons, the pilot, of course, he has to fly, and then the sensor operator, he controls the systems, and he makes also sure that all the data we would like to collect is coming and we are receiving it.
The Lidar surveys capture data to generate digital elevation models. How is this type of data useful for Caribbean countries?
The main results of this data acquisition were digital elevation models, so like surface model, seabed, and also terrain model, and also contour lines. If you are going for hiking, then you know exactly what contour lines are. And also RGB images and orthophoto products. So if you go in Google Earth and you see the imagery, this would be, for example, a product of such a survey. And the development of these digital elevation models and other derived products were critical to the subsequent components of the project. We can use these digital elevation models for different applications. Like in this project for climate change analysis related to sea level rise, for storm surge, for flood modeling and putting designs in place to mitigate the impact of flooding, but also for natural hazard mapping, for land use planning, for all kind of mapping. So also to prepare a map. And nowadays, basically everybody uses a map, basically on the phone nowadays. But when you are going from A to B, then you always need a map, and your navigation system has also a map. So if you are having this LiDAR data, then you can update your maps.
Ainsley gives context to the potential uses of the geospatial data provided through Lidar surveys.
Well, the LiDAR technology is just the newest way of collecting a kind of data that helps in planning strategically to determine where's a good place to put a house or not put a house, put infrastructure or not put infrastructure, the amount of infrastructure that is required in the context of the space. So what this will do is that it will provide data that can then be used to plan the infrastructure and hence prevent things like the coastal flooding that we discussed, and or ensure that you're not building in a space that will result in coastal surges flooding the area. So LiDAR gives you more accurate data that can be used to inform the type of infrastructure that needs to be built, or to inform where and how you put housing or businesses, or even where you store your boats in the case of fishing communities.
Though LiDAR is critical for the analysis of sea level rise and planning, the data acquired through the regional PPCR will be useful in other contexts to advance mitigation efforts.
So in this project, I know that the goal was to use this geodata information for climate change analysis related to the sea level rise, so like storm surge also. Then very important also the flood modeling and putting designs in place to mitigate the impact of flooding. Then to prepare natural hazard mapping, land use planning, transportation and infrastructure planning, and to help to assess the health of the surface of the seabed, so the coral reefs. I know that in this project, these were the main goals, to have this data. Maybe another use, these products can also be used in the forestry for vegetation analysis, like tree inventory, tree count, species, forest limits, for change detection, for volume estimations, and also a very important product would be the canopy height model calculation.
Ainsley has worked on both ends of LiDAR acquisition and application. As program manager, he supervised the capture of LiDAR data. And now, as the head of the forestry department in Jamaica, the organization has an important role in advancing climate mitigation efforts. Ainsley shares how the forestry department plans to use the LiDAR data.
So in my new capacity as head of forestry, we have requested the information that was gathered for Jamaica. And that information will be used as a part of the background to developing our national mangrove management plan. And that will inform how and where we do rehabilitation, as well as where the mangroves are and what sorts of protection are needed. Because mangroves are what are called green engineering. They provide a barrier and a protection for the land from the sea and for the sea from the impacts of land.
Collecting the data is only the first step. The project ensured the relevant stakeholders were equipped in how to use the data.
As a key part of the work that we did under the PPCR program, one of the things that we intended to do was to facilitate capacity building across all 6 pilot countries. The way we did that was to provide training, and we had to do it in a virtual context because of COVID. But we're still able to do it using virtual lab technology. And so we trained the people from all of the countries in the use of the data that was being collected and some of the products and how to use some of that to do some of the planning and other things that needed to be done. So the sorts of people that were trained were forest managers, as in Jamaica. There were people in the planning fraternity, generally. There were people related to coastal zone management, various different professionals that would be able to use that data and able to use that data in the course of the work that they did. We actually ran 2 sessions. One was in English and one was in French. So in the French grouping, we had participants from Haiti, across the length of Haiti in the context of the types of technical capacities that would be needed there. And in the English one, we had people from Jamaica, Dominica, we had St. Lucia, St. Vincent. And there, too, the people were from a multitude of government agencies. I think, unless I'm mistaken, we also had some participation from maybe a CIMH, Caribbean Institute for Meteorology and Hydrology, and also someone from the 5 Cs, which is the Caribbean Community Center for Climate Change.
The availability of LIDAR data for coastal communities and the ability to apply the data to inform planning are major wins for the project, and more importantly, a major win for Caribbean disaster risk reduction and climate action.
Well, I think one of the major successes was what we just mentioned, the fact that we're able to deliver training across all of these jurisdictions. I think we only had one of the 6 pilot countries not represented, and that was due to some logistics issues. But the fact that we're able to deliver training to all of them was a significant plus. At the initial onset, the intent was to do data collection in 3 countries, but it wasn't necessary because many of the countries had already gone ahead and done collection. So we're able to do even more expanded data collection in Jamaica and Haiti. And that information is now available for the technocrats and the planners in these countries to use that information to do significant preventative planning, if you will, to ensure that the impacts of climate change can be mitigated.
Ainsley provides a practical example of how LIDAR is used in preventative planning.
In a Jamaican context, two of the areas that were mapped using the LIDAR technology was the Greater Kingston Metropolitan Region, and the other was St. Mary near Port Maria, etc. And in both instances, there are parts of the coast that are very close to sea level. Preventative planning in this instance would be to use that data because it was both onshore and offshore, and it generated topography and bathymetry, which basically just means the level of the land, whether above or below the water. And what you're able to do with that is you're able to model how the sea will behave under some circumstances. Once you have that information in hand, you can then determine where it's best to put protection, whether in the form of like a seawall, as you see happening downtown in Kingston now, or in the form of a gully or a trench to prevent the flow of water going one way or the other. It can also advise on the amount of drainage that needs to be along a roadside to ensure that, the roads don't get flooded as it does in some places in Kingston right now, whenever it rains.
The acquisition of LIDAR was a data-intensive process for the Caribbean Regional PPCR. What were some of the lessons learned?
I think one of the significant lessons learned is that in the context of working with the international companies that do this kind of work, it's important that you have absolute clarity as to what and how it is that they will go about doing what they're doing. A part of the issue we faced was the delay in terms of delivery, and that was based in no small part to the fact that they had outsourced their work, and with the onset of COVID, it delayed everything. So that is one of the things that I would say is critical. The other is to recognize that when doing LIDAR data collection, one has to take into consideration the time of year because of hurricanes, whether or not it's a rainy season and so the amount of clouds, get prior permission in terms of the areas that you're going to fly, things of that nature. All of this helps to create the atmosphere for a seamless data collection exercise.
The CaribClimate Podcast is produced by the Investment Plan for the Caribbean Regional Track of the Pilot Program for Climate Resilience, funded by the Inter-American Development Bank through the Climate Investment Funds and implemented by the Project Management Unit of the University of the West Indies Mona Office for Research and Innovation. The CaribClimate Podcast, using data to make climate resilience greater.